All right, nerds, let's do some math. So we're talking about complex numbers and operations with complex numbers. So today our main focus is going to be on adding and subtracting complex numbers. So before we get into that, we kind of need to know what the heck a complex number is in the first place. So when we identify a complex number is any combination of a real number and an imaginary number. Real numbers are every kind of number that you've already learned about in every previous math class. Okay? They can be rational, they can be irrational. They can be whole numbers, they can be integers, they can be positive, they can be negative. It's any number that you could really think of, that's going to be what our real numbers are. In a complex number, we identify this a value as being the real component. Okay, so that a is real. Okay, there is no imaginary part about it. It is just a real number. Now, we also need to know that that real value can be 0. Okay, which means that you might not actually see it. It can be 0. It's still going to be a complex number. On the other side of that, we have what we call the imaginary component, and that is this bi. So that is our imaginary number. Okay, the value for the imaginary number is determined by its coefficient b and then the imaginary number, which is obviously I. Just like with the real number value, it can be 0. For the imaginary, this can also be equal to 0. Okay? So what does it mean when it can be 0? Well, we need to think of a complex number as being a combination of a real number, which we're going to call a, and some imaginary number, which we're going to call bi. But within that complex number, a is allowed to be 0. So we might only see bi. Still a complex number, but that's what we would call a pure imaginary because it only has an imaginary component. Okay? Conversely, we could say the same thing if the value of b was 0. So it wouldn't appear as though there was an imaginary component. So we would just see a real number value. We would call that a pure real. But all of these are examples of complex numbers. Okay? So the big takeaway from this is a complex number is any number that can be written in the form a plus bi, where a and b are real numbers and I is the imaginary number. All right? So as we start to work our way through this, we're going to see another very important relationship between real and imaginary numbers, and that comes from this concept, which is the conjugate. We're not going to be looking explicitly at the conjugate today, so I'm going to save this discussion for another time. We are going to continue to use these notes going through all four of the primary operations: addition, subtraction, multiplication, and division. But just to plant the seed, I want you to take a look at the slide and notice what the difference is between the first complex number and the second complex number. There's only one difference that's in between those two. And that one difference is really what makes those two conjugates. All right. So like I said, we're going to come back and do conjugates when we move on to division. So we're not really going to go through and do that in this exact moment. But I want you to remember that word conjugate and think if you can recall what it means when that comes into play later. All right. So now what we're going to do is we're going to go to the next slide and we're going to take a look at a series of 5 example problems for how we're going to do addition and subtraction for complex numbers. All right. So when we are adding and subtracting complex numbers, the name of the game is simple. It is just combine like terms. Okay, before, when we went through and defined what a complex number is, we said it had a real component and an imaginary component. So if we're adding or subtracting two complex numbers together, we need to remember that we're going to combine the reals with the reals and combine the imaginaries with the imaginaries. So to start off with, we're going to take a look at this first example, A. So we have the complex number 3 plus 5i, where the real number component is 3, the imaginary component is 5i, and we're going to add that to negative 2 plus 3i, where the real number component is negative 2 and the imaginary number component is 3i. These are two complex numbers that are being added together. So what are my like terms? Well, in the first binomial that I have here, I have this real number 3 and I have this real number negative 2. My operator that I'm using is a plus sign. So I'm going to say that this must be equivalent to 3 plus negative 2. I also have my imaginary components of 5i and 3i. Again, my operator is this plus sign, so I can express this as a positive, so plus 5i, and then my operator, and 3i. If I go and combine my like terms like this, 3 plus negative 2 simplifies to 1, 5i and 3i is 8i, so plus 8i represents my solution. If I take a look at example B, I'm also going and adding two complex numbers together. So again, I'm going to think about combining my like terms. I have negative 1, I have 3. Those are both my real number values, and my operator between them is a minus sign. So this can be expressed as a negative 1 minus that operator from the middle, 3. My imaginary values are negative 4i, operator of negative, and then positive 2i. So I have negative 4i minus 2i. Combining my like terms, negative 1 and negative 3 combine to give me a negative 4. Negative 4i minus 2i give me a negative 6i. Okay? If I go and look at my third example here, I actually have three things that are getting added together. I have a complex number of 4 plus I. I have a complex number of negative 2 plus 3i, and I have a third complex number that's really just a pure imaginary number that is negative 5i. But I'm still going to do the problem the exact same way that I've done all of the other ones. I'm going to start by identifying all my real numbers, combine them, and then I'm going to look at all of my imaginary numbers and combine them. So I have 4 plus negative 2 minus nothing. There's nothing there, so that's basically 0. So I have 4 plus negative 2. Okay, I'm not going to bother writing plus 0. On the imaginary side, I have a positive I plus 3i minus negative 5i. So I'm going to write that out, where I have a positive I plus a 3i, and then I'm subtracting a negative 5i. Well, I've got a double negative here, so hopefully we remember what happens with double negatives, where they really become positives. So combining my like terms, 4 plus negative 2 is going to give me a value of positive 2. I have I plus 3i plus 5i. So that's going to give me 4i plus 5i, which is 9i. Okay. For the last one, we've got it where it looks a little bit different, but really it's more of just the same stuff. I have three complex numbers, but the first one and the last one are pure real numbers. Okay. So I'm just going to follow my operators and my signs. I have a real number that is 10. minus -4 minus 5. So I'm going to say that this is equivalent to 10 operator minus value of -4, operator of minus value of 5. Okay? So then I'm going to go look at my imaginaries, and I have to look at all the operators first, because this first 10 that's right here, okay, that's still a complex number. That's 10 plus 0i, and that's being subtracted from something. So I need to remember to include the operator anytime that I see a set of parentheses. So I'm going to say this is minus -2i, and that's all the imaginaries there are. So now I've got two cases where I have double negatives. So that tells me that I'm probably going to want to go and change the sign to be addition. And I can combine my like terms to express the complex number in simplest forms. So I have 10 plus 4, which is 14. 14 minus 5 gives me a 9. And then I have a plus 2i. Okay? Sorry, my eyes look more like backwards J's. I'll get the hang of writing on this board. But now we've gone through and we've discussed how to go and add and subtract complex numbers. The big takeaway with all of this is just combine your like terms. So long as you don't forget any of your operators, you should be good to go.